In this video, we are going to basically speak about circular convolution, or in other words, we can call it periodic convolution. So if you are asked to perform periodic convolution between two signals, most probably we can infer it as the circular convolution. Now, consider these two signals, x of k, that is 1, 2, 3, 4, and h of k, that is 1, 3, 5, 7, as shown in the question that is given over here. Now, if you look over here, as per our concept, there should be periodic signals, which means it should be having n samples, which will be spanning from 0 to n minus 1 samples. So here capital N is 4. So here you can infer that it is ranging from x of 0, x of 1, x of 2, and x of 3. And similarly, this will be ranging from h of 0, h of 1, h of 2, and h of 3, meaning that they are periodic in nature. The starting points hence will be 0 for both the signals x of k, h of k, as well as for the output signal y of n, which will again consist of n samples. The length should be n for both the signals, which was explained over here. If not, if they are not of the same length, then zero padding is to be performed. Now, we have a general concept like if the length of the output of circular convolution will be equal to L, which will be max of L1 or L2. So in this case, L1 is also 4 and L2 is also 4. So the length of the output will also be 4. Now we'll take a look at the matrix method for solving the circular convolution problem, which should be a means to get the output in an easy way if it is asked for a short answer question, or in case if you want to verify the answers for your particular problem. So what we do is we draw one of these signals in the form of a matrix. That means 1, 2, 3, and 4 as the column, first column. What we do next is the one element that is at the bottom, it will be brought on top. So it will be 4, 1, 2, and 3. Then the next column will be, this 3 will be coming on top. So it will be 3, 4, 1, and 2. And towards the end, as the last column, you have 2 on top, 3, 4, and 1. There is a reason why I don't write the next column, because if I write the next column, it will be the one that will be coming on top, which is exactly the first column. And that is the case of this particular periodic signal. So we can close this matrix, and we have to operate this matrix with a matrix corresponding to the second signal, 1, 3, 5, 7. And hence, as a result, we'll get the resultant matrix, which will be consisting of the row where you have to multiply and sum up each of the components. So 1.1 plus 4.3 plus 3.5 plus 2.7. Then you have 2.1 plus 1.3 plus 4.5 plus 3.7, and 3.1 plus 2.3 plus 1.5 plus 4.7, and the last row you have 4.1 plus 3.3 plus 2.5 plus 1.7. And when we combine this into the next level, we have 1 plus 12 plus 15 plus 14. Then we have 2, then 3, then 20, then 21. Then we have 3 plus 6 plus 5 plus 28. Then we have 4 plus 9 plus 10 plus 7. When we sum it up, we get the final answer as 42, 46, 42, and 30. What we have done now is the circular convolution problem. with using the matrix method, and we have got the answer. We'll try to solve this problem with the other two methods and see if the answer is also correct. So right now what we are going to try out is we are going to use this particular formula method for solving this particular problem, that is x of k is 1, 2, 3, 4, h of k is 1, 3, 5, 7, and we have to get the result 42, 46, 42, 30, which was obtained in the previous method that we had seen earlier. And now when we go for this particular formula method, it is same as the one used for convolution, except for the fact that you have a notation over here, capital N, which basically refers that it is a periodic signal. Now there would be, if you remember what we had done previously in the linear convolution method, you would have observed the fact that sometimes h of n minus k becomes a negative value, and here a negative value is something that is not acceptable, because we are having periodic signal over here which is ranging from 0 to n minus 1. So negative values cannot be used over here as such. So what we do here is we do a small tweak, and if our n minus k is greater than or equal to 0, we still use it as n minus k. And if our n minus k is less than 0, we tweak it to n minus k plus capital N. So we can start doing this particular problem right now, and we'll see how it goes moving ahead. So we are going to find out y of 0 first. So we are going to start with doing y of 0 first, and when we start doing y of 0, it becomes summation k equal to 0 to n minus 1 x of k into h of n minus k, which basically tends to become h of minus k itself, because n is 0 over here. So we have to write it as the next step, summation k equal to 0 to n minus 1 x of k into h of minus k. So like I mentioned here, it comes to about to be a minus k term. So when we go ahead substitute it, it becomes x of 0 dot h of 0. Fine, not an issue. But when it comes to x of 1, it becomes h of minus 1. And then moving on, we get to see that it becomes x of 2 into h of minus 2, and it becomes x of 3 into h of minus 3. So as per the logic that was mentioned before, if n minus k, that is a value of h of term, is greater than or equal to 0, we still treat it as n minus k itself, not an issue. But if it is less than 0, it has to be added with another factor n, and here n is equal to 4, which is the total number of components in each of these signals. So we can modify it, x of 0 dot h of 0 plus x of 1 dot h of minus 1 plus 4 becomes h of 3, plus x of 2 into h of minus 2 plus 4 becomes 2, plus x of 3 dot h of minus 3 plus 4 equal to 1. So when x of 0 tends to be 1, h of 0 tends to become 1 itself. Fine. X of 1 is 2, h of 3 tends to be 7. X of 2 becomes 3, and h of 2 tends to become 5, plus x of 3 is 4, and h of 1 tends to be 3. So it becomes 1 plus 14 plus 15 plus 12. Summing it up, it is 5. 5 plus 5, 10. And 10 plus 12, it becomes 10 plus 2, it becomes 12, and it becomes 42, which is the first answer that we are to obtain. Moving ahead, if we go for y of 2, we'll get it as summation k equal to 0 to n minus 1 h of x of k into h of 2 minus k. So as we expand it, it becomes summation k equal to 0 to n minus 1. We don't need summation here, so we'll go for the substitution. X of 0 dot h of 2 plus x of 1 dot h of 1 dot 1 plus x of 2 dot h of 0 plus x of 3 dot h of minus 1 it comes about, and it would become x of 0 dot h of 2 plus x of 1 dot h of 1 plus x of 2 dot h of 0 plus x of 3 dot h of minus 1 plus 4 will be h of 3. So when we substitute the values, it becomes x of 0 is 1 and h of 2 is 5 plus x of 1 is 2, h of 1 is 3, x of 2 is 3 and h of 0 is 1 plus x of 3 is 4 and h of 3 is 7. So eventually it becomes 5 plus 6 plus 3 plus 28, 31, 37 and 42. Again the answer y of 2 is 42. Likewise, you can calculate y of 1 as well as y of 2 to get 46 and 30 as your answers. And now what I have just shown is through this video the two methods. One is a matrix method and other is the formula method.